Conda team. So I guess the first panel and like another question that everyone wants to know is, what is the future of packaging? Like, we have Conda, we have Conda Forge, we have Pipeline. How? What's the story there?
I mean, if I knew. No, honestly, I don't know. I think within Python itself, Pip and Conda are probably still going to be huge players. Conda has a role for the cross ecosystem thing, although I will say that, and Marius, you can back me up on this, I think we work best with the Python community by and large. But I don't think we have great insights into how we're going to fix packaging.
Yeah, and I think you'll still see both ecosystems sort of moving along, hopefully working together a little better as time goes on. The pip ecosystem is going to be quite slow, PyPI, but they are interested in sort of working better. So there's a PEP that just went through recently that allows pip to work a little better with system package managers to identify whenever there's packages that it just shouldn't touch. It shouldn't try to upgrade them because they're system. So it is moving forward, and that's not going to go away, and Conda's not going to go away. So, and I think they sort of fill in slightly different roles, and they do work together somewhat. And I hope it will improve. But they do fill different roles. There's certain packages I just could not ship on PyPI that only Conda can do, but PyPI just works in so many different places, and it works with everything rather than having a special Conda Python and Conda shipping everything.
Would you like? The next question is for Conda Forge. Like, is the continuing growth sustainable? Like, are there any plans to cull unmaintained packages?
So we as part of this sort of like the large scale bot stuff, we do know which packages are unmaintained or under maintained. Right now, we don't really purge them. Basically, they, for the most part, the under-maintained packages get very few sort of downloads in any case.
Mm-hmm.
And so largely they're not particularly a big concern. So frequently there is quite a large amount of feedstocks that have been sort of archived over the years. And so that does happen like from time to time as things get removed or deprecated to some serious extent. And feedstock owners do have the ability to sort of like reach out to Conda Forge to say, it's like, hey, this thing is dead now. Please archive it, and we'll do that. And that's been working well enough.
Yeah. And like as Jared just joined us, like, can the scientific Python coordination project and the packaging folks work together? Like, is there anything that is required there? Like,
I mean, I can say a few things. So, yeah, so I haven't actually done much work on this yet, but I have been meaning. So one of the things we would like to do is have a bunch of developer topic-focused summits, and I had on my mind trying to organize a packaging one with pip people and Conda people and other things. So I definitely thought about this issue, and then it's I guess also with CI build wheels, and there's a whole bunch of little pieces that I think would be worth making sure we're thinking through correctly. I mean, yeah. I guess there's the packaging and then the tools to package as well. But yeah, I don't know. Do you have any thoughts on this, or as a packaging?
I'm sort of in both camps a little bit. I really don't want to see them diverge any further, and it can be very easy to think in terms of scientific Python and then the rest of Python, and I'd really like to work together as much as possible, and so scientific Python would be simply an addition to regular Python. And especially in the packaging world, that's a little bit hard because we have requirements that normal packaging community, they don't necessarily even think about at first. Trying to build a tool, and if it doesn't happen to include compiled libraries at all, it seems fine there, but for us, that's most of what we do, a huge part of what we do. But I would like to see further connection. They've been very open. I would say the PyK people are very open to trying to work with us, but we'll have to realize that they sort of move in a bit slower, maybe a bit slower pace than we would like. It's a little slower than, say, Conda might go forward.
Yeah, so this is also a completely technically naive comment, but in my mind, what I would love is that as a maintainer of a package like NetworkX, I'd like to, when I go ahead and make my packages, when I run, build sdist or whatever, it would be amazing if it just made a wheel and a Conda thing and everything worked seamlessly. So I don't know what tooling would look like for that, but yeah, it would be nice if either they merged or like you generated the same thing from one thing. There's also another thing I would like to see is that I think there's some discrepancy between so we have requirements files and they don't all, the syntax doesn't work exactly the same way with pip and Conda, and I think getting all the rough edges out with things like that would be good, although maybe requirements is not even the thing we're going with in the future, but yep.
So one thing I will say, speaking more on the Anaconda side than as a Conda core maintainer, is coordination of schedules is becoming increasingly important, especially as what we think of as production enterprise level Python. And I think one of the challenges there that we've certainly seen on the Anaconda and Conda Forge side is now you start having to worry about things that aren't Python. You have to worry about, well, how long is Windows 7 and 8.1 and 10 going to be supported? Like, what flavor of Linux are we actually going to target? We were talking about CI build wheel, and both Conda Forge and Anaconda default to CentOS 7. But if you start thinking about GUIs like Spider, for example, well, okay, let's build for CentOS 7, but now the newer versions of Fedora and Ubuntu have dropped Xorg, right? They're Wayland by default. Now we have to think about, okay, if I'm going to build a single package for this, can I safely assume I can use X11, right? And if I say, well, do I want to build 2 packages? Do I want to build for 3 different glibcs, to say nothing of like Muscle on Alpine? So I think from the packaging perspective, one of the bigger challenges is like we very quickly start drifting into things that aren't necessarily the Python community and things we as the Python community may not even be able to control.
Yep.
All right, going on a tangent here, like type hints are a thing now, and we have a lot of maintainers here. Hopefully there should be a coherent story that do all packages adopt that, and if they do it, how they do it, are they stubs, are they inline? Do we have any comments here of how other packages are doing it?
Yeah, so this is one thing that at NetworkX, as a NetworkX maintainer, we've thought about is that there's been a lot of interest in type hints, and then the core developer team doesn't really use this. We don't use IDEs, so it's not so obvious to us the benefit, and so we're not experts in it. And then someone who's not a core developer might come in and try to contribute some stuff, and then we don't know whether we should accept or not accept. So we were kind of in this waiting pattern. And so one of the ideas that I've had was in the scientific Python part of the project is this seems like it'd be a really nice spec. If we could get, there's probably a lot of people in our community that know quite a bit about type hinting, but maybe not for each individual project. So I think it would be nice if we could, that's a nice, I think, idea for a spec is that people that know what the right thing to type hint are doing, if that came in and became a spec and then some of the core projects endorsed it, I think the NetworkX team would think, oh, so okay, thank you. Now we know the answer, how to do it. I think there's been discussions about inlining versus stubs. We've been kind of thinking that inline doesn't look as elegant. And then we also use the NumPy doc string, which sort of has some amount of information, but it's not validated in the same way the type hints are. And I also think it'd be nice to think about how to get NumPy doc and the type hint machinery maybe working together a little bit better too. So I think there's a lot of interesting work to be done here, but I think a lot of at least in my experience, a lot of the core developers of packages don't know right the answer is. So I think it'd be nice for the people that do know about type hinting if you could come together and have more universal proposals for what we should do or best practices. It would be helpful. So some people I think knew about type hinting.
I'm a huge fan of type hints. And I'm a big fan of putting them inline because they help you read your code. If you're looking at code you have never read before, or code you're not very familiar with, or code you just forgot because you read it 6 months ago, knowing what types are going through is a huge, huge benefit. It does add more to somebody who's just entering the language, and it's really nice in Python that it is optional, because that means if you're using NumPy, if you're just typing in a notebook, you're not going to add type hints. You don't need to, and you know, you can still use a checker, an ID, and actually get assistance from those type hints. There is an extra sort of. It is a little bit more difficult to read the code when you first see it because now there's more characters. But I'm a big fan of the inline type hints, though. Even though putting them in stubs also has lots of really nice benefits, like being able to just download the stub package and do the check without having to download the entire package and worrying about whether NumPy is actually available for your system or not. Things like that. But I think it's hard. It'll be interesting to see what would come up as a community, because I feel like a lot of people sort of have to approach this because it's a new thing. It's not a required thing. And so some maintainers will come across it. They don't like the look. They think, oh, this makes my code more ugly. And then eventually they will read something and suddenly realize, hey, that type hint helped me understand what that was. This function took a time, a variable called time, and it was a string. So now I know they were passing in this thing. And then they'll start slowly adding them. Eventually you start seeing, if you start using MyPy, then you'll start seeing an effect, and so you start finding some bugs in code. You can almost always, if you go through and fully statically type a code base, you'll almost always find some things that are likely causing problems somewhere. I would say any non-trivial code base you will, because there are mistakes. You'll always find some, and people, the type hints were important because if you look at the NumPy docs, it's literally part of the docs. For writing documentation to people, they put types in. But those types are often wrong because they're not checked by anything. So it's really just documentation that's checked. But it is a bit different for different packages, and it's very different for maintainers, and it's not something you're absolutely required to do, and it's nice that you're not required to do it. But yeah, I think having some guideline would help, but I think it might be a little bit personal too.
So I think something that would probably help quite a bit, particularly in the sort of for type hints, particularly in the sort of scientific sort of Python space, is to get tools like Cython and PyBind 11 to make some of that stuff easier, so that PyBind 11 spits out a shared object, and your IDE has no idea what the types for a lot of that stuff is. And so if a tool like PyBind 11 could also additionally emit a type stub that you ship alongside that thing, then a lot of these things start playing together sort of much more nicely and much more smoothly.
It actually does. So it doesn't produce a type stub. It produces the SO file, but then MyPy has a tool, MyPyC, that can pull out. I think it's StubGen. You give it that SO file, and then it spits out the type stub for you. Because we were doing that before MyPy existed. Some of it isn't formatted correctly for MyPy, though MyPy actually runs PyBind 11 in their test suite now, I believe. Well, once you have the type stub, it works the same thing. Okay. So they have the tool for it. It's not quite ideal, and so ideally we would update our type hints to handle the changes in NumPy, because again, that didn't exist back when PyBind 11 was there, so we didn't have the right signature. And the StubGen actually converts a few of those, I think, for us, just because it's trying to produce the right thing. So that there's some things that can be done there, but it does exist. It's close enough where you can generate the type stub and then just manually clean it up.
All right. I would like to open up to the audience, and if you have any questions for the panel, please go ahead. Yep. I think just yell should be fine. Oh, all right.
Yeah, for the recording, it's better.
Oh, yeah.
I have a question about the usefulness of type hinting in numeric Python. I find that often like having my type hints be function A is an ND array. Argument A, ND array returns ND array isn't that helpful. I would like to be able to say, I have a 2D array of integers, a 1D array of floats, and I'm expecting like a 3D array back. Do you think this is going to be something that we can make possible in even type check?
I mean, there's a PEP that landed,
Oh,
there's a PEP that kind of does that.
Needed a path.
Yeah, it needed a PEP, and that PEP is now in. And so as of, I think, Python 3.11, there's a mechanism that enables that. Now, I don't think anything's using that yet, but I think that's definitely one of those things where it's like that is a spec that we need to write as a community, because it's like NumPy and all array-like things as well as data frame-like things. It's like they should kind of do that, right? I can't remember the number of the PEP, but it's like something. It's like
646. We have another question.
646. Hey, Riddle, you just want to say the mic 646 was the name of the PEP?
The name of the PEP was 646.
Thanks. Thank you.
Someone on the panel said. Yeah, I was just kind of wondering, recently Apple, for example, unveiled this M1 chip, and my team's experience was that, we actually had a little bit of trouble with builds for a while. And as that kind of thing happens, the grid of versions and hardware architectures and everything starts to grow. It becomes more of a resource drain on some level to provide coverage. And I'm wondering if you all have thoughts about acquiring resources, or partnering with the hardware manufacturers or public clouds or anything like that, in order to kind of keep up with what's sort of a growing ecosystem, I guess.
Yeah, in an ideal world, yes, right. Like in an ideal world, Apple would have provided M1 for a lot of the scientific Python community before it fully launched. But the reality is, it's hard to get the resources. I know we were talking about on Python 11 supporting Windows on ARM, or sorry, CI. Windows on ARM with CI build wheel. We're starting that similar conversation on the Conda side, but to their credit, Microsoft is starting to engage with our community on it. But the last I heard from them, the issue they have is they don't have the hardware themselves, right? So we're slowly, cross compilation gets you some of the way there, but it obviously has, you have to pull tricks, and then how do you test it? I know CondaForge, we do a lot of cross compilation, and and emulation, and you still end up with how do you test it? And interestingly, going back to my earlier comment, with the hardware especially, ARM is an interesting thing for us to start thinking about, because ARM v8 covers a diverse range of hardware, right? And so, for example, on CondaForge, we build against basically the baseline ARM v8 implementation, which will run on everything from Raspberry Pi to AWS's Graviton. But then again, as you start thinking about what I'm going to call production use, now you have these interesting questions where, portability for a lot of us package maintainers it takes priority over everything else, right? As a user, if you're deploying on the SBSA, so server grade ARM, are you willing to live with that potential drop in performance, right? And if you're not, who do you go engage with to, what do you do? Do you build special wheels? Do you build special Conda packages? And then it comes back to the maintainers of, well, if we build these special, different builds, like how do we distinguish between them? And I think, it would be great if we could find CI resources anywhere. But the reality of it is like, it just costs everybody money, right? I think with CondaForge, as Marius and Wilf were explaining, like, we moved everything pretty much to Azure. except for a few stray things, but there's an overhead we have to pay. And I don't know if we have any great solutions for it, other than maybe asking companies to donate more to NumFocus so we can go buy CI time.
All right, so we have a question for NumPy. Like, how would the how would the new work on ufunc and implementing D types integrate with pandas and pandas D types?
Yeah, so the pandas D types, they have an extension mechanism which is quite different. It works on a slightly different level compared to the NumPy one. My hope is that we can integrate the two, and I'm not sure how exactly that should look like, whether we would make an extension array, what pandas calls it, that supports the NumPy D type, so you would have like an intermediate thing, or whether we can teach pandas to just work with NumPy D types directly, which I think should be possible. I did not look into this much yet, so I don't know exactly how difficult it will be. I don't think there's any serious issue why pandas shouldn't just be able to use the new NumPy D types. It uses NumPy D types already. It's just a few more now, basically. But there will be issues and there will be things that need to be fixed up and consolidated.
Right. Do we have any more questions?
Okay, so many of our domain libraries like to take an input called an array-like. How do you feel about deprecating the term array-like? So when I'm thinking about list of lists or list of lists of lists of lists, like deprecating the term array-like so that everyone just takes arrays and not array-likes anymore. In NumPy, I guess. NumPy created the term array-like, I think.
Yeah, I guess the term array-like is a bit unfortunate, and also because we have the thing that list of lists are array-like for NumPy because it can be coerced, but then we have other now array-like objects which are actually tensors, like JAX tensors or PyTorch or whatnot. So I personally think it might be worthwhile to think about retiring the support for these list of lists that is implicitly supported everywhere, just because it will make the interoperability with things like Torch and JAX easier from a user perspective. If you always convert everything that can be converted to a NumPy array, it can be very confusing when like JAX enters, which also can be converted to a NumPy array, but probably you don't want to convert it to a NumPy array. So I don't have an idea of what to replace it with. Just calling it array might also be confusing, because then which library are you talking about?
And NumPy.asArray makes the old legacy stuff.
Well, yeah, sure. NumPy as array would keep doing whatever. That's certain. But libraries, especially libraries, I think, could choose to not support like nested lists. I think that makes sense. The transition is interesting.
Right. Do we have any more questions?
I think there are a few very specific questions to the related to the talks. So I would like to invite all our speakers to go in a channel and answer those questions there. And if there are no more questions in the room,
Yep.
I think we would like to thank the panel again and for your participation in the audience as well.